Is matter around is pure? A mixture contains more than one substance, element and or component mixed in any ratio. If the mixture has a uniform composition throughout, then the mixture is called a homogeneous mixture. If the mixture has non-uniform composition and has physically distinct parts, then the mixture is called heterogeneous mixture. A solution is a homogeneous mixture of two or more substances. The major component of a solution is called the solvent and the minor component is called solute. Therefore, solvent plus solute gives solution into 100 gives mass of solute by mass of solution into 100. The concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution. The particles of a solution are smaller than 1 nm into 10 to the power minus 9 meter. So, they cannot be seen by naked eye. Mass by mass percentage of a solution is equal to mass by volume percentage of a solution is equal to mass of solute by volume of solution into 100. Volume by volume percentage of a solution is equal to volume of solute by volume of solution into 100. When no more solute can be dissolved in a solvent at a given temperature, the solution is called saturated solution. The amount of solute present in a saturated solution at a given temperature is called its solubility. If the amount of solute contained in a solution is less than the saturated level, it is called unsaturated solution. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Colloids are heterogeneous mixtures in which the particle size is too small to be seen with the naked eye, but is big enough to scatter light. The particles of colloids are called the dispersed phase, and the medium in which they are distributed is called the dispersion medium. Heterogeneous mixtures can be separated into their constituents by physical methods like hand picking, sieving, filtration, sedimentation, evaporation, sublimation, distillation and fractional distillation, etc. A physical change brings about a change in the state of matter without change in composition or chemical nature of the substance. The chemical change brings about a change in chemical properties of matter because one or more substances are transformed into new substance. A pure substance can be an element or a compound. An element is a form of matter that cannot be broken down by chemical reaction into simpler substances. A compound is a substance composed of two or more different types of elements chemically combined in a fixed proportion. Properties of a compound are different from its constituent elements, whereas a mixture shows the properties of its constituting elements or compounds. Activity Aim: to observe and compare homogeneous and heterogeneous mixtures. Materials required: 4 beakers, 50 ml each. Water, copper sulfate powder, potassium permanganate, common salt, sodium chloride. Spatulas. Procedure: divide the class into 4 groups A, B, C and D. Group A takes a beaker containing 50 ml of water and 1 spatula full of copper sulfate powder. Group B takes 50 ml of water and 2 spatula full of copper sulfate powder in a beaker. Group C and D take different amounts of copper sulfate, potassium permanganate or common salt and mix the given components to form a mixture. Observe the color and textures of the mixtures obtained by all the groups. Compare the mixtures obtained by group A and B with the mixtures obtained by group C and D in terms of their uniformity in color and texture. Note down the observations. Observations: Group A and B obtained homogeneous mixtures, while Group C and D obtained heterogeneous mixtures. Homogeneous mixtures have a uniform composition throughout, while heterogeneous mixtures have physically distinct parts and have non-uniform compositions. Examples of homogeneous mixtures are salt dissolved in water and sugar dissolved in water, while examples of heterogeneous mixtures are mixtures of sodium chloride and iron fillings, salt and sulfur, and oil and water. The intensity of the color of the copper sulfate solution obtained by group A and B is different, which shows that a homogeneous mixture can have a variable composition. Activity Aim: to understand the effect of temperature on the solubility of a solute. Materials required: 2 beakers, 50 ml each. Water, salt, sugar or barium chloride, stirring rod, heat source. Procedure: take approximately 50 ml of water each in 2 separate beakers. Add salt in one beaker and sugar or barium chloride in the second beaker with continuous stirring until no more solute can be dissolved. Heat the contents of the beaker to raise the temperature by about 5 degrees Celsius using a heat source. Start adding the solute again with continuous stirring until no more solute can be dissolved. Note down the observations. Observations. At room temperature, the amount of salt or sugar or barium chloride that can be dissolved in water is limited. While the solution is heated, the solubility of solute increases and more solute can be dissolved in the water. The solubility of different solutes varies with temperature, and the solubility of some solutes may decrease with an increase in temperature. The effect of temperature on the solubility of a solute is an important factor in many industrial processes. Activity Aim: to prepare a mixture of iron and sulfur and observe the properties of the obtained material. Materials required: iron fillings, sulfur powder, china dish, magnet, carbon disulfate, dilute sulfuric acid or dilute hydrochloric acid, filter paper, beaker, stirrer. Procedure: divide the glass into 2 groups and give 5 grams of iron fillings and 3 grams of sulfur powder in a china dish to both the groups. Group 1. Mix and crush the iron fillings and sulfur powder. Group 2. Mix and crush the iron fillings and sulfur powder. Heat this mixture strongly till red hot. Remove from flame and let the mixture cool. Check for magnetism in the material obtained by bringing a magnet near the material and checking if the material is attracted towards the magnet. Compare the texture and color of the materials obtained by the groups. Add carbon disulfide to one part of the material obtained. Stir well and filter. Add dilute sulfuric acid or dilute hydrochloric acid to the other part of the material obtained. Perform all the above steps with both the elements separately. Precautions: the teacher should supervise the activity as it involves heating the mixture. Handle the chemicals with care and avoid inhaling the fumes. The magnet should be handled with care and kept away from electronic devices. The filter paper should be properly folded and fitted into the funnel to avoid leakage.